All right, so page 186, the elevator questions. Number 21, which I kind of already did. A 64 kilogram person is standing on a scale in an elevator. So half of you already saw this one because I did it by mistake. Okay, so here's the person standing on a scale in the elevator. Here is FG acting down. Here is FN acting up, and we know that FN is F scale. And so it tells us the mass is 64 kilograms. And the question says the elevator is rising at a constant velocity, but then begins to slow down with an acceleration of 0.59 meters per second squared. So it's going up but slowing down. So if it's going up but slowing down, it means its acceleration is downward, right? If its acceleration was upward, it would be speeding up. So the first question is, what's the sign on the acceleration? Assuming we call up positive, then the acceleration will be negative. And then what is the reading on the scale? So sum of the forces in the y direction. So it should be F scale minus Fg is equal to MAY. So F scale should be equal to MAY minus Mg. So F scale will equal 64 kilograms times negative 0.59 meters per second squared minus 64 kilograms times 9.81 meters per second squared. And remember, this 9.81 goes in, whoops, this is a positive, goes in as a positive because we already looked after the direction of the FG right there. Okay, so F scale then will be equal to 590.08 newtons. This would be the apparent weight. If you wanted the apparent mass, you would take this and divide it by G. And when you divide 590.08 newtons by 9.81 meters per second squared, you get an apparent mass. And no, the textbook didn't actually ask you to do this, but I will on the test, I promise. 151 kilograms for the apparent mass. Number 22, 75 kilogram man standing on a scale. Fg is acting down. F scale is acting up. Elevator begins to descend with an acceleration of 0.66 meters per second squared. And again, it wants the direction. So it's going down and speeding up, so its acceleration will be downward. Assuming we call up positive, then the acceleration will be a negative. And then it wants the reading on the scale. So sum of the forces in the y direction will be F scale, again minus Fg if we're calling up positive, equals MAY. So F scale will equal MAY plus Mg. F scale will equal, 75 kilograms times negative 0.66 meters per second squared plus 75 kilograms times 9.81 meters per second squared. And you get an F scale to be 686.25 newtons. That's the apparent weight. If you want the apparent mass, again, divide this number by G. And when you do that, you get an apparent mass of 69.954 kilograms. Number 23 says a 549 Newton person. That's the FG. 549 newtons. This is the F scale. You can find this person's mass by doing Fg divided by G, and when you do, you get the person's mass to be 55.96 kilograms. 9633 to be exact. Okay, so you do some of the forces, in the y direction, but I think I forgot the a part. So let's go back to the question. Elevator, it's going down at a constant velocity and the elevator begins to slow down and eventually comes to a stop. So the elevator is going down, slowing down, which means the acceleration must be up. Okay, so assuming we're calling up positive, this will be f scale minus fg is equal to may. So f scale will equal may plus mg. So m 55.9633 kilograms times positive 0.73 meters per second squared, and they told us mg was 549 newtons. 94, yeah, 49. And so F scale ends up being 589.8532 newtons. And again, if you want the mass, divide your 589.8532 newtons by 9.81 meters per second squared, and you get a mass of 60.1277 kilograms for the apparent mass, not the real mass, just what the mass appears to be because of the movement. All right, going back to the sheet, we need to do number 22 because we ran out of time. So number 22, an 80 kilogram person standing on the scale of an elevator. Okay, so this is 80 kgs in here. Going down is Fg, going up is F scale. And it tells us the elevator begins to accelerate upward at a rate of 1 meter per second squared. Okay, so accelerating upward, so that's an up. Do some of the forces in the y direction. So it should be F scale minus Fg equals may, assuming up is positive. F scale then will equal may plus mg. So F scale will equal 80 kilograms times 1 meter per second squared. That's about 80 newtons plus 80 kilograms times 9.81 meters per second squared. So that's like 10 times 80. So F scale ends up being 864.8 newtons. That's the apparent weight. The apparent mass will just be that number divided by 9.81, and you should get 88.155 kilograms. You should show me the work, but I'm trusting, I don't want to run out of time, and I'm trusting that you know I divided by 9.81 here, meters per second squared. B wants to know what is the apparent weight and mass of the same person as it begins to slow down. So it's still going up, but it's slowing down. So now its acceleration is down. So again, it'll be F scale minus Fg equals may. So F scale will equal may plus mg. So 80 kilograms times negative 1, because it's going down this time, plus 80 kilograms times 9.81 meters per second squared. So 8.81 times 80. And so you get an F scale for the apparent weight to be 704.8 newtons. And then the apparent mass, because I have 30 seconds left, will be F scale divided by G. And when you do this, you get 71.845 kilograms. Okay, so hopefully elevators make you happy now. All right, very good. And yes, you should show me you should do this on the test. You should show me the step. I just skipped it because I knew we were going to run out of time momentarily.